We have seen the basic fundamental terminologies and definitions in the previous lecture. Link is in the description box. Understand the types of fit which is possible in between the mating parts. So there can be three types of the fits possible depending upon the type of motion in between the shaft and hole. So number one is the clearance fit. So clearance fit, whenever there is a clear relative motion in between the shaft and hole, that fit is called the clearance fit. In this case, if this is the shaft and if this is the hole, in this case, shaft size will always be less than the hole size and the tolerance zone of the hole. So if this is the tolerance zone of the shaft and this is the tolerance zone of the hole, then this zone will be entirely for hole will be above than that of the shaft. So this is called the clearance fit. So clearance fit examples are wherever there is a relative motion in between the shaft and hole. So what are those options or examples? So this is piston and slide walls, number one. Second is the bearing of pumps or motors. So there is a clear motion in between the shaft and hole. So these types of fits all are called the clearance fit. Number second fit is the interference fit. So what happens in the case of interference fit is that the shaft size, so this is the shaft, so tolerance zone of the shaft is above than that of the hole. So this is the hole and this is the shaft. So shaft size will be always greater than the hole size. So how these fits occur? So in this case of interference fits, elastic strains develop on the mating surfaces during the process of assembly, and in future there is no relative motion. There is no relative motion in between the mating parts. So this is very important. So what are the basic examples of the interference fit? So the tires on rail car wheels. Other example is pump impeller on shaft, pump impeller on shaft. So these are the example of interference fit. Now in between the clearance fit and interference fits, the other and last fit comes the transition fit. In this kind of fit, the tolerance zone of shaft and hole, there is a overlap or transition, and this is the tolerance zone and it overlaps in most of the situation. So neither clearance fit nor interference fit, so in between there is a interference fit. So now what are the example of transition fit? So it is a basically transition fits are to use where repeated assembly and disassembly has to be done in the shaft and hole or the mating parts. So what are the examples? So example for the mating parts, wherever we use quarter joints, keys and pins, etc. So depending upon the uses or application, transition fit is given in the shaft and the hole. We have seen the three different types of fits, that is the clearance fit, transition fit and interference fit. Now the allowance between the hole and shaft can be obtained in two ways. So there are two types of system. So one is hole basis system and the second one is the shaft basis system. So what is the difference in between two? In the hole basis system, the hole is kept constant and the shaft is varied. So shaft size is varied, where the reverse is in the case of shaft basis system, that is the shaft size will be constant and the hole size will be varied. So there is a possibility of two types of system, hole basis system and shaft basis system. So one more thing is that in any of this system, whether it is a hole basis or shaft basis, the maximum metal condition corresponds to the basic size, and for the hole, the maximum metal condition will be its low limit. So now we are looking at the uh, a hole basis system. So here we can see, so this is the clearance fit. So shaft tolerance zone is on the lower side than that of the tolerance zone of the hole. And second is the transition fit. So we can see here that the tolerance zone of the hole and shaft are overlapping, and in the third case the tolerance zone of the shaft lies above than that of the hole. And so this was the hole basis system. In the case of shaft basis system, so first we have to fix the basic size. So here the basic size is fixed, so this is corresponding to the high limit or maximum metal condition of the shaft. So this is the basic size. Now for a case of clearance fit, hole tolerance zone will lie above than that of the shaft tolerance zone. For the transition fit, the hole tolerance zones are overlapping than that of the tolerance zone of the shaft. And this is the third case, that is the interference fit, where the shaft tolerance zone lies above than the tolerance zone of the hole. So these are the three clearance, transition and interference fits, and how they will be decided in the case of a hole basis system and the shaft basis system. So there are different types of system for defining the tolerance zone, and International Organization for Standardization for any basic size. So if this is the basic size, then there are possibilities of 28 different size of hole. So these are the holes and these are the shafts. So there is a 28 different sizes of the holes and 28 different sizes of the shaft. So holes are denoted by capital H or capital letters, whereas the shafts are denoted by the small letters. So small h is the basic and capital H is the basic size of the hole. So we can see here the capital H is the basic size of the any hole, and the basic size will correspond to the low limit of that hole. Similarly, for this shaft we can see small h, the high limit of a small h is corresponding to the basic size of the shaft. So this is the International Organization for Standardization, how they have defined the various holes and different sizes of shaft. So to specify the various tolerances across the this basic size, there are different tolerance zone, that is the 18 grades of tolerances have been defined. 18 grades of tolerance zones or grades have been given. Now these 18 grades of tolerance zone are defined by one fundamental tolerance tolerance I. So this I is given by 0.45 cubic meter cubic root of D plus 0.001 T, and this value is in the microns. So this I is the fundamental value of tolerance, and the other tolerance 18 tolerance grades are defined in terms of this I. Therefore, if we draw this curve between the fundamental tolerance I and this basic size D, then we will have a curve like this. So as the basic size increases, this implies tolerance grade or fundamental tolerance I will also increase. So that may lead into a problem. What problem is there? Suppose if there is a suppose basic size increases from 25 to 27 mm, then the tolerance will change. Therefore, to simplify this, diameter steps have been made, and the tolerance grade will remain same for that diameter range. So how International Organization for Standardization has divided the diameter steps as 1 to 3 mm, 3 to 6, 6 to 10, 10 to 14, 14 to 18, 18 to 24, and so on. So like this, the ISO has given the diameter steps, and basic size will be the geometrical value of the upper and lower limit of the diameter is, that is the under root of d1 and d2. So earlier relation I is equals to 0.45 cubic root of d plus 0.001 d is for dia up to and including 500 mm, whereas for dia of size more than 500 mm, the tolerance value I will be given by 0.004 times dia plus 2.4 m microns. So this is the basic fundamental tolerance. Now how to determine the tolerance grade based on this fundamental tolerance. Now these are the various tolerance grades. So IT 5, 6, 7, 8, 9, 10 up to 16. From IT 0, 1 to 5, IT 05, in between the values form a geometric progression. Whereas IT 0 is given by zero point 0.5 plus 0.012 times of dia. IT 01 is given by zero point 0.3 plus 0.008 times of dia, and IT 1 1 is given by zero point 0.8 plus 0.02 times of this dia. From now this IT1 to IT5, the in-between values form the geometric progression. Now let's take an example. Suppose we have given a hole and shaft assembly by a designation. Suppose this is 50 H 8 and this is C7. So what does it represent? So 50 is the basic size of the shaft. H is the type of hole. Small c, so it's a small c is a type of shaft and it has tolerance grade 7 and hole has tolerance grade of 8. So what does it represent? So it represents, if we go and see this tolerance grade 8, it means that this is IT8. So IT8 will be given by 25I and IT7 for shaft will be given by 16I. So this is the basic representation, and this H8 and C7 we can see from this diagram. So this is the H and this is the C. If we zoom in this slightly, so we can see this is the H and this is the C. So it is a it is a kind of clearance fit between the hole and shaft assembly. So this is the basic representation of any shaft and hole. Now further we'll see through the numericals how to determine the allowance, tolerance and other values for any given hole and shaft assembly.